Hey everyone, welcome back to another session of carbon and its compound. In my previous session, I have already finished with the topic of nomenclature and how you can make structural isomers. In today's session, I will be starting the chemical properties of carbon. But before I start my session, I would like to request you all to kindly subscribe to my channel and share it among your friends and family. So let's begin today's session. Now, the chemical properties of the carbon, the first chemical property is combustion. Okay, so combustion means heating a substance strongly in presence of air. That is, whenever we are burning anything, that is simply a process of combustion. So if you see the allotropic forms of carbon, allotropic forms means physically they are very different from each other, but chemically they are same. Like we have done the allotropes of carbon like coal, we have also done diamond, then graphite and fullerenes, right? So they all are physically, that is their physical appearance is very much different, but they are chemically same. They all are having carbon in them. So whenever they are burnt, that is simply the carbon inside them will burn, right? So whenever they are burnt, that is carbon in presence of oxygen, they will produce carbon dioxide plus heat and light. Okay, so the same thing, this chemical reaction is written here, that during combustion all the allotropic forms of carbon are oxidized to form carbon dioxide with release of large amount of heat and light. Now if you see the next point is that during combustion all the organic compounds, so here basically we are talking about the hydrocarbons, let us say CH4 or C2H4, right? So if you take any one of them, product will be carbon dioxide plus water plus heat and light. Now water is there, why? Because they are having H in the reactant. In the reactant we are having H. So obviously that H will change to H2O by the addition of oxygen, that is whenever they are burnt. So CH4 whenever burnt with oxygen or C2H4 whenever they are burnt with oxygen, they will always give you carbon dioxide, water plus heat and light. So this is a combustion process, and in this combustion process what we are seeing, that the carbon dioxide and hydrogen to water with release of large amount of heat and light. So this is the process of combustion, and simply if it is a carbon, then if it will burn in presence of oxygen, it will give you carbon dioxide plus heat and light. If it is an organic compound like methane or ethene, then they will give you carbon dioxide plus water, because they are having H in their reactant. So from there you can remember the H will change to H2O, and heat and light obviously. So let us try to understand more points in the combustion itself. Now whenever we see the combustion of a saturated hydrocarbon in our previous sessions we know that it is alkane, right? Like methane, ethane or LPG gas which comes in our home, which is used for cooking, it is having mainly inside it propane and butane, right? So this is what? This is a saturated hydrocarbon. They all are alkane, methane, ethane, propane, butane. So whenever they are burned in excess of air or oxygen, they burn with a blue flame. So blue flame is their characteristic flame when they are burnt. But whenever the unsaturated hydrocarbons are burnt, now the unsaturated hydrocarbons are alkenes and alkynes. They are alkenes and alkynes. Okay, like here examples are written ethene, ethine or benzene. They always burn with a yellow flame. They burn with a yellow flame. They do not show blue flame, okay, with lots of black smoke. Now why is it so? See, in case of the unsaturated carbon, the carbon content is always high as compared to the hydrogen content. Okay, their carbon content is high. Like for example, you can take the example of, let us say, first I am writing alkane, ethane, let us say. Ethane is C2H6. Okay, and if I am writing here ethene, it is C2H4, right? Now here you can see that the ratio between the carbon and hydrogen is 2:6, that is 1:3. Okay, here it is 2:4, that is 1:2 ratio is there. So you can see that here the carbon content is very close, okay, to the hydrogen content. We are comparing the carbon content of the unsaturated to saturated. Okay, so the carbon content of unsaturated compounds is more than the hydrogen content, and therefore some of the carbon remains unburned, that is, it is not completely burnt, and this unburnt carbon deposits as soot. So soot is what? Soot is simply the unburnt carbon. It is simply the unburned carbon. Okay, so they give us yellow flame along with soot. Whenever the unburnt carbon particles are there, so they will form soot, or you can also simply say it as the black smoke. And why it is so in case of the unsaturated hydrocarbon? Because in them the carbon content of unsaturated hydrocarbon is more than the saturated one. Okay, and sometimes we also see that saturated hydrocarbons burns with yellow flame, but when they are burning in limited supply of oxygen. They are burning in limited supply of oxygen. A very good example will be that you all are aware with the burners in the home. You all have seen the gas burners like this, and they are having holes. Here they are having holes. Okay, so why these holes are there? So that the gas which is coming from the cylinder, the LPG gas which is coming from the cylinder, it can come in contact with sufficient supply of oxygen, and then it will burn with blue flame. Okay, if these holes are blocked, if the holes are blocked, then you will be seeing that the soot will be there, that is, the bottoms of the utensils will have the carbon deposit on them, or the unburned particles, or the soot will be there, and it means that at that point of time the gas is not getting sufficient supply of oxygen, and it is getting burnt in limited supply of oxygen, and that is why we are seeing that the bottom of the utensil is getting blackened. It is all because of the that the gas is not getting sufficiently burnt in the proper supply of oxygen. Now if you will see in our surrounding, we are also having lots of other things also, like you must have seen the burning of the coal. Now when you are seeing the burning of the coal, you will see that initially it burns with flame, okay. Wood or coal, if you will observe them, they will always burnt initially with flame, but later on they are only burning, okay, and they are very, like, the color which is coming is red hot, that is, the flame is not there, okay, no flame. Okay, why is it so? It is because flame is always produced when gaseous or volatile things are getting burnt. Gaseous or volatile materials or compounds get burnt. get burnt. Like for example, in the beginning, whatever gaseous material is present in the coal or the wood, it will burn, and for that time only we will see the flame. But once that particular thing is finished, once the gaseous thing is finished, no more volatile substance is there, so we will not see the flame. That is why later on they just simply keep on burning and they become red hot, but they don't show us flame, because by that time all the volatile substances are already burned in them. Okay, on the other hand, there are certain things which keeps on burning with the flame, that is they are gaseous in nature itself, or they are volatile. Now let us start with our next chemical property, that is the oxidation. Oxidation is simply what? It is the addition of oxygen to any substance. This topic you have already understood in the chapter 1. And the substance which are capable of adding oxygen, they are called as oxidizing agents. That is, the one who is giving the oxygen is called as oxidizing agent, and reaction is called oxidation whenever there is an addition of oxygen. Okay, combustion is also a kind of oxidation reaction, like we have done there, that CH4 plus O2 changes into CO2 plus water plus heat and light. Okay, there are certain reactions in which there is an incomplete or partial oxidation. Now in the case of the carbon and its compound, we see that they easily gets oxidized and changes to the acid. So this is an alcohol. Okay, its name is ethanol. So it changes to ethanoic acid. Ethanol changes to ethanoic acid. Okay, by the action of alkaline KMnO4. This is alkaline KMnO4 and this is acidic K2Cr2O7. Okay, either one of them, not both of them, or okay. So whenever alkaline potassium permanganate and acidified potassium dichromate are added, they always act as a good oxidizing agent and they add oxygen to alcohol. As a result of that, the alcohol changes into acid, that is ethanoic acid. So alcohols to carboxylic acid change, you will see whenever you will heat alcohol with either alkaline KMnO4 or with acidic K2Cr2O7. This is acidic spelling, I have written wrong, sorry. So why is it so? Because they both act as good oxidizing agent. They add oxygen to alcohol. Once oxygen is added to alcohol, it will change to acid. So here I have written example of ethanol to ethanoic acid along with water. So this is the oxidation reaction. The next reaction is called as the addition reaction. As its name is telling us here that addition means addition simply. So a process where, or a reaction in which you see that two reactants are getting combined to form a single product are called as addition reaction. This definition also you are aware from the chapter 1. Now if you see in the case of the carbon compounds, we are having the alkene and alkyne. This is an example of alkene because it is having a double bond. Okay, and then this is an example of alkyne. It is having triple bond in it. Right. Now if you see a simple alkane, let us say alkane, and if you take its example of C2H6, that is ethane, its name is ethane. Now see, between carbon-carbon single bond and H around every carbon atom. Remember, around carbon you need 4 bonds basically. So 1, 2, 3, 4 for this carbon, 1, 2, 3, 4. Now see, this is a saturated hydrocarbon or a hydrocarbon where there is a presence of single bond between carbon and carbon. This kind of hydrocarbon, that is alkane, they are saturated, that is they are happy because like around every carbon there is a single atom okay, and there is a single bond. So it is completely saturated, it is happy. But in case of the unsaturated hydrocarbon, you can see that between carbon and carbon double bond is present. Okay, here if you see this one, between carbon and carbon there is a presence of double bond and there is one H here. Okay, but there is a little bit tension between the two carbon atoms since they are having double bond between them. They are not as free as compared to an alkane or a saturated hydrocarbon. Now same goes for the alkynes. Between carbon-carbon there is a triple bond and with a single hydrogen atom. So here also the tension is much more because between carbon and carbon there are triple bond. So it is not as relaxed as a saturated hydrocarbon. It is not that much relaxed. It is like the atoms of carbon are under stress here also, and here they are not under stress. So obviously the unsaturated hydrocarbons are more reactive. So the same thing is written here, due to the presence of the double and the triple bonds, the unsaturated hydrocarbons are more reactive. Okay, so they also want to become like an alkane. So what will happen? As soon as you will add hydrogen to them, they will quickly accept it and they will make a single bond. Like when you are adding H2 to the ethene, this is ethene, what will happen? Here, let us say this is H2 I am adding. So quickly it will accept these two H, one will go to this one will go to this one, and they will retain their previous hydrogen atom around them. Okay, and they will change to CH3, like this is CH3 and this is also CH3, right? So they will quickly accept it. They will quickly, the incoming H2, they will accept it because they also want to become like an alkane. They also want to become stress free. Same goes here. Here we are adding 4H, 2 into 2, 4H you are adding here. So what will happen? Here this structure will change to single bond between carbon and carbon. It will retain its single H. Out of the 4H, 2H will go here and 2H will go here, and they will also form the ethane. So they are coming to ethane, that is alkane or a saturated hydrocarbon. This is ethyne. So they want to become like a saturated hydrocarbon. Okay, simply because in this case between the carbon we are having single bond and they are not under stress. So as soon as you will add H2, they will quickly accept it and they will change to the saturated hydrocarbon. Now this addition reaction has got an application which is also popularly called as hydrogenation reaction. So what happens? The addition reaction is commonly used in hydrogenation of vegetable oils. See, vegetable oils are unsaturated hydrocarbon. Now what are vegetable oils? Oils which are in the liquid state, like in home you know that there is a sunflower oil. Okay, this is a very common one. Okay, so the oils are basically the unsaturated hydrocarbons. Okay, so whenever in unsaturated hydrocarbon you are going to add hydrogen, like here H2, vegetable oil which is in the liquid state, and if you take the catalyst like nickel, or we are also like we are having other catalyst also nickel is there, then we are having platinum is there. So what will happen? They quickly increase this process. They quickly allow this process to happen. So what is a catalyst here? Catalysts are basically substances which increases the rate of reaction, So they will allow the reaction to occur fast, but they are not involved. That is, they will not combine or they will not form any new compound. They will come out as such. That is, nickel will come out as such at the end of the reaction. They will only allow the fastening of this reaction. Vegetable oil, it is unsaturated, so when it is heated with the hydrogen at 473 Kelvin with the nickel, it will allow the quick mixing of vegetable oil with H2, and it will change it to vegetable ghee or any solid saturated hydrocarbon. It is a saturated hydrocarbon here. Okay, but they will not form, nickel will not form any kind of compound in the chemical reaction. So basically nickel, platinum, palladium, these are the catalysts. So why there is a need of this kind of reaction? Why we want this kind of reaction to occur? We want this kind of reaction to occur because vegetable oils, when they are left exposed to hot and humid weather, that is when they are left open for a very long time, they turn rancid. Now rancid is what? Rancid means that this vegetable oil will change to carboxylic acid or aldehyde by the action of oxygen and moisture. That is what we are saying, that when the vegetable oils are left open or they are exposed to hot and the humid weather, that is, there is a presence of oxygen. So what will happen? That because of the presence of the oxygen, the vegetable oil will change to carboxylic acid or to aldehydes or both of them, and because of that they will develop unpleasant smell and taste. This unpleasant smell and taste will develop in the oil, and it will not make the oil you can say in a very good state, or it will become unconsumable. So we need to get rid of this rancidity process, and to remove this reaction to occur, we add hydrogen to it to make it ghee, because hydrogenation reduces the number of unsaturated carbon chains and slow down the development of rancidity. Okay, so in this way we can keep the oil for a longer time, and that is why it is used in many industries also. The hydrogenation reaction is used. Now the vegetable oils are good for health. Why we say so? Because the vegetable oils contain unsaturated hydrocarbon in them. On the other hand, the saturated carbon chains, that is the ghee or you can say butter, they are not said to be that much good for cooking purpose. They are not good for cooking purpose as compared to vegetable oils, because the saturated fat increases the level of bad cholesterol. It is also called as LDL, okay, which sticks to the walls of the arteries and thus causes coronary heart diseases. So it increases the bad cholesterol level, which is also called as LDL, low density lipoprotein, and it sticks to the walls of the arteries, and thus it causes the heart problems. And that is why the saturated fat should not be eaten in a very large amount. It should be eaten in a limited amount. Second, it should not be used for the cooking purpose. Cooking can be done with unsaturated vegetable oil of your choice. Now the next reaction, the next chemical property of the carbon is the substitution reaction. Substitution means is very simple, that is, it is a direct replacement. It can be a displacement or substitution of an atom, either a single atom or a group of atoms, okay, in an organic molecule by another atom or group of atoms without any change in the rest of the molecule are called as substitution reaction. Okay, so here I will tell you the example. Basically, in the addition reaction, we have understood that alkanes never want to undergo in a chemical reaction, okay, easily. Why? Because they are saturated, or they are happy, in a very simple word, because they are having the single bond between carbon and carbon atom, but they can undergo in a replacement or a displacement kind of reaction, okay, which is also called as a substitution reaction, okay. So this kind of reaction is possible, not addition. This is a substitution where the another atom or a group of atom can be replaced, but that also will not take place easily due to the presence of the carbon and carbon single bond and carbon hydrogen single bond. Saturated hydrocarbons are unreactive and are inert to the actions of the reagents, but in the presence of high heat or light, chlorine reacts rapidly with the saturated hydrocarbon to form substitution products. Like here you see, this is methane, CH4 is methane. So methane will react with Cl2 in presence of sunlight, and when the temperature is very high, it will change to CH3Cl plus HCl. Like for example, if you draw its structure, methane here, this is methane, single C, and it is surrounded by 4 single bonds with H, right? Now when you are attaching Cl here, so what will happen? One Cl will replace this H and it will form CH3. This side will become CH3, this whole side, and instead of this H, Cl will come, and this H which is coming out, it will combine with another Cl to form HCl. So its name is chloromethane. Chloro is used as a prefix, and then CH3 is single carbon compound, so it is methane. So it is chloromethane. Now this reaction can occur further also, like this CH3Cl, or you can simply say that if we are writing CH4 here, this reaction can keep on occurring, like CH3Cl, if it is again subjected to Cl2 in presence of the sunlight or high temperature, what will happen? This will again, like if I draw its structures, H here, H here, H here, and Cl here, and this is Cl2. Now this Cl, from this Cl2, one more Cl will kick this H out and it will take its place, and this H will combine with this Cl. So we will get what? CH2 now. This side will become CH2 and Cl2 will become 2. One is here, another Cl will take this place, Cl2 plus HCl. Now the name will become dichloromethane here, because it is a single carbon compound and there are 2 chlorine atoms. Now if this one is again subjected to more of Cl2, again one more Cl will go here, it will kick one more H out, so we will have CHCl3 plus HCl. This is called as trichloromethane now. Okay, this trichloromethane, if it is further subjected to more of Cl2 in presence of the sunlight, everywhere sunlight or high temperature heat you will have to mention. This is the symbol of heat I am drawing. The Kelvin will be same here. Everywhere it is sunlight. Okay, in the presence of the sunlight or very high temperature, again this Cl will kick this last H out and it will form CCl4 plus HCl. Its name is tetrachloromethane, or we are also calling it as tetrachloride. Trichloromethane is also called commonly as chloromethane. So it is carbon tetrachloride or tetrachloromethane. Okay, so this is all about the chemical properties of the carbon, and they are very easy to understand like you will have to just go through the chemical reaction, and theory you can learn very quickly, because whatever you're writing in the chemical reaction, most of the part is occupied, like the same thing you will have to write in the writing. Out of this, the main topic is the hydrogenation reaction, which is usually asked in the terms of the vegetable oil to ghee or the saturated hydrocarbon conversion. I hope you will be able to understand the chemical properties of carbon after going through this session. Thank you and have a good day.